Any questions from the audience? Hands? It's like bright, bright. Okay, yes, sir.
Yeah, let's talk about design of models. How much of it, as a percentage, time is spent on thinking about the maintenance of that model when you're designing? As new complex opportunities come at us, how much time are you carving off and saying, can I maintain this model once I have it in place?
Sure. Did you guys get that? The question was a lot of the talk about designing a model. How much time do we spend thinking about what it's going to take to maintain that model in production?
So which bit are you worried about maintaining, the code or the data?
Well, exactly. I think about word to vec versus a sequence to sequence. As you get to like R&R, RNN networks and stuff, it gets pretty complex. And to me, it screams potential challenges in production.
So that's definitely true. I would say that code maintenance is not much of a problem because most of these solutions only take of the order of a few hundred to a few thousand lines of code to implement. Much more significant are problems about train test skew where the data that you trained on initially doesn't represent the continued stream of data that you're dealing with. Also, at the moment, the software ecosystem around these things is very unstable, and so you get a lot of operational complexity from that. But I would say mostly, actually, it comes down to data more than the code. But yeah.
And I would add to that if you're going to use something in production, you think about it a lot. So a lot of best practices around if you're standing something up as your own web service with a machine learning model behind it, you want to monitor that. You also probably want canonical test training or test examples that you can send to your endpoints to ensure that their behavior isn't changing or stays within an acceptable range over time. And another thing that's you need to think about but is really tricky is if you are putting a model into a production setting where you're going to retrain that model over time using training data that has now been influenced by a previous version of the model. And that's tough. And you gotta think about some pretty creative ways to help deal with that.
Next question. Please wait for the mic so we can get you on the camera and recording. It's put through.
Yeah, hi Patrick. So I totally understand why you would want to use sigmoid activation functions for the output in Word2Vec, but what yields the best performance, what activation function yields the best performance for the hidden layer, typically?
So in this example, there was no activation function for the hidden layer, so not using one. The sigmoid activation function for the output layer makes sense because that's a final classification layer, and you do want to get to a close to 1 or close to 0 prediction for that layer. Okay,
so using nonlinear activation functions isn't recommended for a hidden layer Word2Vec?
Conventionally, it's not used in the existing Word2Vec implementations that are out there. For some of the model architectures that Matt talked about in his talk that are use these kinds of embedding models as an input often, then have very sophisticated recurrent or convolutional layers on top of that, and those will use a whole variety of different activation functions.
Right. Great. Thanks.
Sure.
Time for 2 more questions. All right. Taryn, you want to come down? I'll run around. Oh, you got a mic? Okay, we got help.
Awesome. I had a question I guess for Matt, but for both of you. And on the attend layer, I sort of understood the whole thing, except for then you said, okay, this is a weight that sort of, it's a weighted sum of these matrices. How is that? Is that just a matrix multiplication, or is there like a whole nother network architecture happening in there? Is that where the label data comes in? I was sort of confused by that piece that seems really important.
Yeah, so I was a little bit vague there because actually, compared to the other ones, the attention layer is, there's a bit more fudging there because there's a number of different mechanisms which people refer to as attention. I guess the thing that's sort of most fundamental to it that they all share in common is coming up with some sort of matrix that you can then reweight things, reweight the individual inputs by, where the reweighting matrix should have columns that sum to 1. So people often do use a a multi-layer perceptron to transform the input before they put it into the attention layer, but other people don't, and the attention layers all have different shapes and things. So it's definitely something that's a bit more variable than and a bit less nailed down than the Word2Vec and LSTM and things layers which people are using.
One more question?
A question for Ines.
Yeah.
So one of your examples, the one around compensation, you phrased it as a classification problem. Do you have any recommendation for phrasing it as a segmentation problem, meaning you want to find the right span? And in your example, I thought actually the span, I would have taken the stock options in the span as well, not just the amount in millions.
Yeah, I mean that's clearly something you can try out. I mean, my example was mostly trying to show how you can use the token attributes, but in the end, like I said, I don't have a perfect answer for this. This is something you'd have to explore, and it's an unsatisfying answer, but it depends on your data that you're working with. So it's okay. For example, you could try using an interface that actually highlights spans and try to teach your model to highlight the respective attention span first, and then try to maybe use a named entity model on top of that to extract the specific parts of it. That's all stuff you can try. So basically the idea here is, okay, if you have good tools that let you try this out quickly, you can run this over your data and find out what actually works, because the truth is there is no perfect solution. It depends, and the goal is not to find the perfect solution. The goal is to enable the data scientists to actually try out all things they can come up with that make sense and find the one that actually works in that case. So, thank you very much.